Hello, this week we're going to talk about data pre-processing using RapidMiner, which is one of the most time-consuming tasks in learning analytics. And I'll leave the first 5 slides for you to read yourself, like how to download and open datasets. Instead, we'll start from slide 6 to slide 32, I believe. Yes, slide 32, just before the assignments, so that we can go through the basic pre-processing features in the RapidMiner. And you might find me pause for a while during the lecture, and that's because I'm trying to read the PowerPoint to give you exactly what's demonstrated in the PowerPoint, but with more details. So bear with me. And I haven't yet found the best way to show both the PowerPoint and the RapidMiner. So I'll just show the RapidMiner for now, unless I feel that there's something I need to point out in the PowerPoints. Sounds good? All right, let's get started. Okay, so from slide 6, it tells us to go to TurboPrep panel or tab. Just click it, and this is the place where we can do all this cool data pre-processing stuff. And it asks us to load the data. It's under the samples, data, and the Titanic datasets, a classic dataset for machine learning. So if you double click it, or you can just click the load data button, the data will be loaded. And then for slide 7, it tells us that we can hover over a column or a feature. That's how I'm going to call these columns. If you hover over a feature, you'll be able to see, oh, come on, really? Uh, okay, heads up, you need to click on the feature. Like you need to make it orange before you can actually hover over it to show the details. That's nice to know because I never actually used this thing. But you see, you can get some descriptive statistics like the average, maximum, and minimum from this continuous data. And it will be different for um, the category data. And the thing that I use the most to get descriptive is actually just right click on the feature and then click show details. This will not just give me a table of stats, but also a distribution of the data, which gives me a better sense. So you will probably want to do this instead. Um, and for slide 8, oh, that's part of slide 8. And then another thing in slide 8 is that it asks us to click the transform button, and then we will be able to transform the data um, as we want. So for slide 9, it introduces the range and sample. So one thing to note about the range is that it's trying to select the data between the row number. It's not like, like a filtering criteria, say the value is between 1 or 100, 1,309. It's actually the row number. So if I change it to 20 to 30, it actually means that just keep the data between row number 20 and row number 30, right? And the sample, I guess that's more straightforward. It just means that randomly select a fixed number of sample from the data sets, or you can just do percentage. And in slide 10, we have this other thing that we can do. For example, we can rename a feature, and we can change the type of a feature. For example, age, as you can see, the type is number, and sex is category. If I decide that I want to make sex a number, I can just use change type to do that. But that doesn't make sense because sex is actually category, right? But sometimes I guess the RapidMiner is smart enough to get the type correctly, but sometimes you just have to make sure, like, go through your data set to see whether it actually makes sense for the type. If not, you might want to change the type yourself. And then remove just means that we will want to remove the whole feature or the whole column, and we can also make a copy of the feature. So you might wonder why do I need the copy, right? Because sometimes we want to just for example, we want to transform the feature to another new feature, but we also don't want to lose the old feature. An example is that if I copy the age, let's say like age category, that's the new name of the feature. Um, you see right now these two columns, these two features are exactly the same, but I can, change this from number to category somehow, like below 10 years old, between 10 and 20, and above 20, something like that to make it different from the category. And that sometimes can actually give you different predict power. So that's something you might want to try. But this is just random. I'm not saying that you should try it for the age, but for your own data set, you might want to, play with your data and do some transformation. And that's what they call feature engineering. And let me get rid of the age category. I'm gonna use the remove button, right? And apply. Ta-da, it's gone. Okay, now let's go through the practice in slide 10. This stuff here on the right side. And I'm gonna move it away and then do that one by one. So the first one said change the name of age column to age from capital A to lowercase a. So transform, rename age. All right, see, it's lowercase now. And then second, remove the cabin column. Okay, this is totally random. Nothing's wrong with cabin. It's just poor. Remove it, apply. Bye bye. Okay, number three, copy age, which I just did. Which I just did. Copy it and name it whatever you want. Say I want to name it copied, age copied, and you see that I have both age and age copied exactly the same value because that's what copy does, right? And number four, filter out passengers older than 29 from the age column. Okay, I'm gonna use filter and then says older than 29, so greater than sign, and then 29, apply, yay. Okay, we only have people who's older than 29 now. And number five, draw a sample of 130 cases. So I'm going to use sample and then 130 cases and apply. So we should only have 130 rows now. If you don't believe me, be my guest. Actually, it tells you here 130 rows. Um, and next, commit transformation. So far, what we have done is all temporary. It's not like saved, unless we click the button commit transformation. So I'm gonna do that, and it's saved. It's committed. And don't worry if you want to, regrets, because we can always use the history to go back, which I'll show very soon. So now in this number 7, it says exported in CSV. So we're going to click the dot 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 button, export, and then click CSV here. And next, I have a folder for learning analytics course. I'm gonna just name it My Titanic. Okay, save it. And if we want to check it, um, don't worry about it, this fancy terminal thing. You can use your Finder and File Explorer to find it. I just don't want to show you my secrets, right? It's not shareable. Just kidding. So if I double click the new saved file, my Titanic.csv, we should open the Excel if you have Excel. If you don't have Excel, it might be numbers for Mac or other software. So you see I'll transform the data here. All right. And then the next thing, the last thing, what is this? Okay. And the last thing is roll back before the first step. So we want to go click history, and then it says before the first step. So the first step is rename, and we want to roll back before it. So we just click it, make it orange. and then roll back before this step. All right. Okay, proceed. Okay, now you see the age has become capitalized again, and we still have the cabin, right? Cool. So that's it for transformation, for transform. And now we're going to view slide 11, which is cleanse. Okay. So for the data cleanse, the first three thing is actually applying the cleaning to the whole data sets. It's not about a specific feature or a specific column. It's about whole data sets. So the auto cleansing will do several things, which I listed here in the PowerPoint. It will try to remove the data that matches with this criteria, all right? Or actually do something with it. For example, the PCA. We'll talk about it later. Don't worry about it if you don't know what it is. But the takeaway is that these three things actually applies to the whole data set. That's why they're not grayed out, even though you're not choosing any column or any feature. And then for slide 14, is talk about remove low quality. And the low quality is defined by the columns for which certain quality thresholds are not met. For example, if we have too many missing values, you'll see like those question marks in the data sets. If you, let me see, yeah, you see the question marks. If we have too many question marks in a column, under a column, then this column will be likely to be removed. And then the other thing is that if it is not supposed to be like ID, what it means is that every value is different because ID is supposed to be different, right? If you have a unique ID, it should be unique. But sometimes it shouldn't be that way. If it is not an ID, but it's actually but the values under that column all have different values, it probably means that it's not very useful for our analysis because we always want to try to find something in common, between these two different rows. Because usually one row will be a one entity, for example, one student, one teacher. So if they don't have anything in common, then it's kind of useless for us to make some predictive power out of it. So that's why it will be removed. And for slide 15, it talks about the remove correlated columns, which just means that if two columns or three columns they are highly correlated, only one of them uh, will be kept. All right, the other columns will be removed. And cleans. Okay, so now we're getting to replace missing. All right, so for replace missing, as the name suggests, it just means that we want to replace those question marks with some certain values. And the most used thing for continuous numbers, for continuous values, is actually using the average, because you are not actually adding more information if you're using average. You see, because if you're using average and then the average of the column will still be the same. Make sense? And then for the category, it will be the most frequent value. For example, if you see this, this is not a good example. If you see male the most, then the missing value you replace will be also male. All right. So that's for the replacing missing value. We also talk about some more fancy methods for replacing missing values in the future, which is called imputation. So conceptually, what imputation does is that you just use a linear regression model to predict one of the columns. And then, for example, if I have some missing value in the sex column, I have some question marks, and I want to find where exactly the sex is the passenger. I might use the passenger class, age, number of sibling, these kind of features to predict what the sex will be for that passenger. So that's the big idea, but the details is kind of very complicated. And for sex, you can see that actually instead of building a linear regression model, it might make more sense to actually use some NLP model to guess that through the names, because usually we can tell whether a person is female or male through the name, right? Not always, but most of the time. So that's just some idea. And for the next slide is normalization. Okay, so normalization is just a fancy word to say you want to center the data, or somehow change the scale of the data. By scale, I mean like the range and that kind of thing. And the most used approach is standardization, which you might be familiar with if you have taken some stats course. Which just to make this value z value or z score. That's the most commonly used technique for normalization. And next one is discretization. So using discretization, we can transform a continuous value variable to a categorical variable. Remember the example I talked about before, like I copy the age and try to make it category like below 10, between 10 and 20, and above 20. So that's some way to discretize a continuous variable, but you have better or more automatic way, which is using binning. So basically, what it means is that we want to, for example, let's see what's the range of this age here. It says minimum is almost 0 and maximum is 80. So we can probably have 8 categories by using 8 bins. So if I do this and you see equal ranges and I apply, you probably see that we'll have 8 ranges. So the equal range just means that for each range, for each bin, it will have the same range. For example, range 1 will be probably from 0 to 10, and then 11 to 20, something like that, to divide the values into different categories. So that's what the discretization do. And then dummy encoding, and that's something very useful actually. So for dummy encoding, what it does is that it turns one column into several new columns based on how many unique values you have under the column. For example, we have 3 unique values here, none, 7, 5. Then we will have 3 new columns uh, created by dummy encoding. And then the values under the new columns will be binary, 1 or 0. 0 means false, 1 means true, or false, 0 means no, 1 means yes. So for example, the first row, the LB equals to none is 1, and the other 2 are 0. It means that the passenger has no lifeboats. And for the second row, none, 0, LB equals to 5, 0, LB equals to 7, 1. So it means that the passenger is in lifeboat 7, number 7. I believe this is the lifeboat what's that the lifeboat number. And then interestingly, you actually can see that it's actually highly correlated with the survival status. If they do have a lifeboat, they tend to survive. If they have no lifeboats, then it's most likely no, they didn't survive. So which makes sense, right? That's very straightforward, I guess. Um, Okay, PCA, Principal Component Analysis, quite a fancy word. So it is the technique to reduce the number of numerical columns by creating a smaller number of numerical columns, which are linear combinations of the original ones, while the data variance is kept. All right, can I speak English? Yes. So think about this. Um, if we have 50 or 40 variables and they're all numerical, all right, they're not categorical, because if you select categorical variable, you won't be able to apply PCA to it. So you can only apply PCA to numerical variable. Imagine you have 50 or 60 inputs or columns in your data sets. and and lots of them actually explain the same information. Like they bear the same information about the dependent variable, and so that we actually don't need that many features. One way to do that is to use PCA to reduce the number. And what we can do is that we select the numerical variables, and then we choose PCA and apply it. The threshold is 0.95. I'll explain this later. Apply. And then you see we have new two variables and the old variables are gone. They're transformed, they're compressed into these two new variables. So the maximum new variables you can have is the same original number of variables you actually apply PCA on. For example, I selected 4 variables, and then the maximum new variables I can get is 4. But why I only have 2 here is because I set threshold to 0.95, 95%. So for each component or each new variable in the PCA, they will explain a certain amount of data variance. For example, let's say component 1 explains 60%, and component 2 explains 35%, and component 3 explains 2%, and component 1, I don't know, component 4, I don't care. So we only need the first two components because component 1 explains 60, component 2 explains 35. We add them up and it's already 95%. So that's enough for us. That's enough data variance explained by the new variable. So that's why we only have component 1 and component 2 here. Make sense? So if I set the threshold to say, let's change it. Okay, I got the variables back. If I set the threshold to say 99%, oh, still two component. Let's try 1. You see that I have 3 component now because 2 component is not enough to explain the 100% of the variance. So it's not if even though I choose 1, it's not always for I will not always have 4 new components, 4 new variables. It depends on how many variants you can have already, or you can already explain by the new variables. All right. So you might ask, why do we need PCA? Probably 4 reasons. The first reason is that variables can be correlated and there is redundant information in these variables. So we can just use PCA to get rid of the redundant variables. And the second one is it might be faster for the model learning if we have less features, if we have less columns. Imagine that you have now we only have over 1,000 rows and probably I don't know 11 columns. That's not a lot. So we probably shouldn't use the argument that we want to make the model training faster in this case. But imagine that you have 50,000 rows and 100 columns in your data sets, and you're trying to use some fairly complex machine learning models such as gradient boosting tree that we will cover in the later section. And this can be really slow if you have that many data and also that many features. And that's the point that you might want to use PCA to actually reduce the number of features, right? And the third argument might be we want to avoid overfitting. So in machine learning, what we usually do is that we separate the whole data set into 2 data sets or 3, sometimes 3. But let's say we only have 2, okay? We separate into a training data set and a testing data set. So a training data set is something that we actually feed to the model. We actually let the model see and learn from this data. And then the testing data set is something that the model has never seen before, so that we can test on this unseen data to see whether the model is generalizable. The overfitting describes the phenomenon that the model performs really well during the training phase, but very poorly in the testing phase. So this can happen when you have lots of features in your data sets, and you're trying to use some classical machine learning models such as logistic regression, SVM, or decision tree. This kind of fairly simple model. You tend to overfit when you have lots of features. So one way to do that is to use PCA to reduce the number of features, but it's not a guarantee. It's something worth trying, but you cannot always avoid overfitting by just reducing the features. And finally, you might want to use PCA when you want to visualize the relationship between your features against the dependent variable, your y's. Again, imagine that you have 50 or 60 features in your data sets. How are you going to visualize them, right? The best we can do is probably 3D, three-dimensional. We can have three features against the dependent variable, but now we have 50 or 60. So it's very challenging for us to do that. So the one technique people often use is to use PCA to actually reduce these 50 or 60 features into three or two features, so that we can actually visualize like how they what's the relationship like is like between the features and the dependent variables. Um, and that's it for PCA. All right, let's do the practice in slide 22 together. Um, the first one says replace missing values in the age column by average. Replace missing by average. Apply. Okay, done. And second, normalize age column using standardization. Normalization, standardization, all default. Easy peasy, hopefully. Yay. Okay. And number three, compute principal components from age, number of siblings, number of parents. Age, control click, number of sibling, control click, number of parents. And then we have these three. Or you can just, oh, I thought you can drag it. No, you can't. So you have to control click it. And using PCA, it didn't say the threshold value. I'm just gonna use the default one, 95%. And we have two new variables, new components. And then the last one, do dummy encoding for passenger class. Passenger class. The first one is the passenger class, and then dummy encoding, apply. And you'll see that we have two new columns. Passenger class equals to second, passenger class equals to third. Oh, there's no first. Oh, yeah, first, sorry. Three new columns. And that's it. And if I commit cleans, I'll keep the changes, and which I don't want to do. I want to go back, roll back to before this step. All right. Okay. All right. So now let's go to slide 23. We're going to load some new data set now. Let's remove this. Right click on the data sets, and then remove it, or you want to keep it. Make sure you export it. Okay, and remove load data, and we need the Titanic training and Titanic unlabeled. So let's import Titanic training first, and then Titanic unlabeled. And for slide 24 is telling us to it's introducing the merge, which we're using appending. So this is the simplest merge we can do, which basically means that we just put the data in one data set into another without using any relationship. So that's appending, or sometimes you can see that as concatenating. And let's go to slide 25. We're going to click the Titanic unlabeled and click generate. And then on slide 26, we need to type a column called survived. Remember the S is capitalized. And then we are going to drag missing nominal to the formula. So missing nominal basically means that it's a nominal data or categorical data. So because this is unlabeled, we don't have any information whether this passenger survived or not, and we also don't have the column called survived. And what we are doing right now is that we are adding a new column called survived and filled all the value with the value missing nominal, which is, I guess, null or something like that. And we need to click update preview, and you see, oh, it's actually question mark. And we need to commit generate to keep the changes. Okay, we add a new column survived to the Titanic unlabeled. The reason why we want to do this is because the Titanic training data set, the Titanic data set is actually about predicting whether a passenger will survive based on the other features. So we have this data set that does not have any, that does not have the column of survived, so that we cannot actually predict if we want to combine this data together. That's why we need to add this new column. And then in slide 27, we're going to click merge. Actually, click Titanic training first and click merge. It actually doesn't matter. It's just if we click Titanic training, the Titanic unlabeled will be appended after it, so it will be below the Titanic training data sets. Otherwise, it will appear first. But let's just follow the PowerPoints. Click the Titanic training and merge, and then select datasets Titanic unlabeled, and we're trying to use append for the merge type. All right. Remember to update the preview, or you cannot commit the merge. So update preview, and then you'll see that we have the new data here. You see they have two different colors, blue and green. All right. And you see that the Titanic unlabeled actually appears after the Titanic training because we choose the Titanic training first. And then commit merge, right? And that's basically, I think, for the append. Yes, that's it. So now we have come to slide 29, which is a very interesting or a very useful technique for data pre-processing. So normally, if you're dealing with relational data, like especially if you're doing some MySQL database data, they have some kind of relationship. Like they are using some foreign key. What they call foreign key is actually just some ID to referring to each other. For example, we might have in the PowerPoints, we are using the product and transaction. It's actually here, product and transaction. Yeah, sorry for moving this. So we have the product and transactions. So we can actually somehow relate these two different tables or different data sets together, because you tend to have some product ID in the transaction to suggest what product the customer bought. So we can just use that ID to actually connect these two data together. All right. So that's what the joining is for. And we have three types of join. Well, actually four. The first type of join that you're going to see very often is inner join. So inner join is just to find the overlapped area between the first table and the second table. And by table, I mean you can just imagine them as Excel sheets or two different data sets. So we want the overlapped area between these two different data sets. And why? Because you might want to need features from both data sets, not just only one of them, so that you can use inner join to make sure that your data will always keep the information from both data sets. So that's why you will use the inner join. And the left join or the right join is that we prioritize the data from one side. For example, if we have table 1 and table 2, and if we are actually getting some overlapped area, like the middle parts, it means that for the data in this area, it will bear both features from the table 1 and table 2. But for this part, the left parts, it will only bear information from table 1. So the features from table 2 will likely be like missing. So if you're fine with this, you can just do the left join or right join. And the outer join is just like you don't actually care about whether you will have information from both tables at all. You just wanna join them or merge them uh, horizontally. Like appending is like merging data vertically, right? You like data one, you have data one, data two, data three, and then from the data set one, and you have data four, data three, data four, data five from the data set two. And for appending, you're merging them vertically, just put them from bottom to top. And then for the outer join, it's like horizontal. It's like you have feature one, feature two, feature three from data set one, column one, column two, column three from data set one, and column four, column three, column four, wait, column four, column five, column six from dataset two, and then you just horizontally merge these two dataset together so that your dataset will have uh, feature from your dataset will have column one, column two, column three, column four, column five, and column six. That's what I mean by horizontal and vertical. Okay, and to join, let's see, it's slide 30 now. We want to load the data of products and also load data of transactions. So let's see what columns we have in the data set. In the products table or in the products data sets, we have product ID, product name, category, and price. In a transaction, we have customer ID, product ID, and amounts. So what they overlap is that they both have product ID. So that's where we can start to join them using product ID. And let's go to slide 31. And first we want to do, let's see, what's the first step? We want to click merge, and then we want to choose products. Oh, it's already choosing products. Actually, let's go back. We want to choose transactions first, and then click merge, and then choose products. Merge with products. And the merge type will be left join. So which one is the left? Which one is the right here? The transaction is actually the left because we prioritize transaction. That's the thing we click first and click the merge button. So the transaction will be the left table and products will be the right table. And choose the key product ID and product ID. You see that if I show the drop-down menu, you'll see that it's 100% match. It means that every transaction can find the product ID. Sorry, we can find the all the products in the product ID in transactions. All right. So let's update the preview, and you see now the table has not only not only the columns from transactions, but also the columns from the products. Quite neat, right? And we can commit merge. Now we have a new table, transactions, right? And slide 32. Oh, that's just some commands for programming languages like R and Python. So that's not something you need to worry about. If you are interested, you can try them if you know these two languages. All right, that's basically it for the PowerPoint walkthrough. All right, so for the assignment, you're going to do lots of merging, especially using joining to process the data. The reason why the assignment is this way is because merging data is a very common thing for learning analytics. And for example, like here we have the assessments table datasets and also the courses datasets and also student assessment datasets. So if we join this table together, we can get how students perform in the assessments and what the assessment is about, and also what courses the students has taken and what the courses are about, so that we can use all this information to predict whether how the students will perform, based on the information we join together. So this is why we designed these assignments. And feel free to come to the office hour to discuss any challenges or difficulties you have come across. And also, I'm also always free to schedule a Zoom meeting with you if the office hour doesn't work. So just let me know if you have any questions, or you just want to, have some conversation. All right. Good luck with your first assignments and happy rapid mining. Bye bye.